C.3 of homework 1 questions, part 3. 3 questions from number 9 through number 11. Question number 9. When we apply the bubble sort on an array, so you need to know the details of the bubble sort. If we know that this array contains at least one inversion, okay, then we have to do at least one swap operation. Okay, so here you need to understand the relationship between inversion and swap operation. Okay, yeah, here inversion. Definitely you need to know the concept of inversion first, then swap operation. Okay, yeah, the relationship between these two. Yeah. So when you have an inversion, yeah, so more specifically adjacent inversion, right? Yeah. Because the bubble sort of works on an adjacent inversion. Okay, yeah. Then the swap operation can change that, yeah, because one swap operation targets on one particular adjacent inversion. One swap operation targets one adjacent inversion. Okay, yeah. After that swap operation, that the adjacent of inversion, that one is gone. It's gone. Yeah. So you need to know that kind of detail. So then you can answer this question. Yeah. But here, if I go to another level, yeah, because for the relationship between these two, I can go to another level. So probably because after this homework 1, we will have the midterm test. The midterm test, so I will extend the questions we have so far to another level details. Yeah. So here I can do in this way. Yeah. All right. Given an array with certain number of inversions, right? So let's say with S inversions. Okay, yeah. S greater than 0. So that means it is not sorted. Yeah, S greater than 0. Yeah. We do the bubble sort. Okay, so we do the bubble sort. Yeah. Now, after one swap operation in the bubble sort, okay, yeah, we know the S number should be reduced, right? The S number should be reduced, right? Yeah. Here the question is, how many? How many of S could be reduced? Okay, so that question, yeah, that question. Although you do not need to worry about this one in homework assignment number 1, but I have some chance to give this kind of question to you in midterm. Okay, all right. So here I just, use this chance to give you some idea about the midterm, because we will have midterm soon. Yeah. All right. Question number 10. When we use the linear search on many different input arrays, yeah. Sometimes we have unordered arrays, and sometimes we have ordered arrays. All possible. All these cases are possible. Now, which of the following statements about the efficiency is correct? Here we're talking about the linear search. Okay? Yeah. Only linear search. Okay? All right. A. We will get better efficiency whenever we process the ordered array. Okay? Here when we talk about efficiency, we mean the meaning is number of comparisons. Okay? The number of comparisons. So that's our meaning. Efficiency. Better efficiency means fewer number of comparisons. Okay? Yeah. Fewer number of comparisons. All right? Yeah. So whenever we process the ordered array, you cannot predict which one is ordered, which one is unordered. Okay? Yeah. The input arrays come in randomly. Okay? Yeah. Randomly. Yeah. Sometimes ordered, sometimes unordered. All right? Yeah. So that's the situation. All right. B, we will get better efficiency whenever we process unordered array. C, we will get the same efficiency no matter we process the ordered or unordered arrays. Same efficiency, here we mean same number of comparisons. All right? Yeah. Same number of comparisons. All right? Yeah. In general. All right? Yeah. Or we can talk about the average, right? Average case. Yeah. Because efficiency, you have best case, worst case. Yeah. Here, because the overall efficiency, we use average case. So here, it's better we use average case efficiency. All right. Yeah. But another thing I want to talk about, I want to make clear. Yeah. Do not use the binary search. Okay? Because when you see ordered arrays, some students may connect to binary search immediately. Okay? May connect to binary search immediately. Don't do that. So why? Because sometimes you have unordered arrays, right? If you use binary search, you cannot process unordered arrays, right? Here, we want to process all possible arrays. Okay, yeah. We need to process all possible arrays. Yeah. So that's why no binary search. Okay, no binary search. We want to use one algorithm to process all arrays, all possible arrays. Okay, all right. Otherwise, you may use the wrong way. Yeah. So you may think about when we have ordered arrays, we use linear search, but when we have when we have unordered arrays, we do linear search. But when we have the ordered arrays, we do binary search. Yeah. But here, how do you check the given array is ordered or unordered, right? You need to check. When you check, you need to spend a lot of time. Think about that. You need to check. But here, we do not check. We just apply the search directly. So that's why I say only linear search. No checking. Okay? No order checking step. Okay? Yeah. All right. So that's the right way to understand this question. Yeah. All right. So the last question of this video, this one, number 11. Which of the following growth functions has the highest, remember the highest, not the lowest, order of growth? That means the largest, right? Yeah. All right, here, first, the formula you need to know, the first one, we talked about this before, right? This expression equals n. Yeah, so this is the main formula we need to use here. Yeah, we know here we assume A. Yeah, how about that? Yeah, what's the condition? A positive and A not equal to 1, right? Yeah. Under this condition, then we can use this formula. Okay, all right. Yeah. With that formula, you can get A, we will get n, right? Yeah, because A equals pi. B, we will get also n, right? Because A equals golden ratio phi. Yeah. So then the main step, C and D. C and D, yeah. Because it is hard to see what is the simple form of C and D. Okay, so you need to represent C expression as n to some number power. Okay, yeah. And for D, you also need to represent it in n to certain number power. Okay, all right. But how to represent it? Yeah. So that's the tricky part. How to do that representation? So that's the tricky part. Yeah. Yeah. Still use this formula. We use this formula. We can do that conversion or transformation. Okay. Yeah. But we did one example before. Here I like to give you the reference of that example. Yeah. So it's this one. Yeah. All right. So you watch this example, this video, module 2, part E.3. Video E.3. Yeah. So you can find this video. Yeah. And this question. Okay. In that one, I give you the details how to convert similar representation of that in the form of n to certain number power. Yeah. Then you can compare these two numbers. So which one is larger, which one is smaller? Then you can answer this question. Yeah. All right. So that's the all the questions I want to explain in part C of module 4. All right, so let me stop this video right here.